have to ask it.
That's a building, okay? So I have a building and I'm standing 200 feet away from the base. Now try not to look at the picture, just kind of look, because it already gave you a picture, right? But when you go ahead and do the problems on the test and stuff, usually you have to build your own pictures, correct? So kind of not look at it, because then you kind of get the basis of what they're doing instead of what you should be doing. Does that make sense what I'm saying? Because then it already gives you an idea. Okay, so it says that we are 200 feet from the building. The angle of elevation, once again, what is angle of elevation? When you're looking up, right? Everybody understand that? Okay, so as we're looking up from the bottom of the smokestack, which is on the top of the building. Okay, so we have a smokestack. That's my smokestack. Okay, you're looking up, and the angle is 35 degrees. So you're looking here the first time, and it's 35 degrees. Does that make sense to everybody? Pretty simple, pretty easy to solve question. It's not too shabby. Okay, so with that being said, now it says blah, 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 whereas the angle of elevation to the top of the smokestack is 53 degrees. So we looked at the bottom of the smokestack, and then we went to the top, and it created this other angle, which is 53 degrees. So technically we have two triangles, don't we? Okay, do we know the height of the building? Does it tell us anything about the height of the building? No, so we're going to call that a x. No, it's 53, so you have 35 degrees here, then you're instead, like, okay, for example, if I'm looking at the top of the cupboard, my eyes are going to the cupboard, right? So I've looked there, that's the first angle measured. Now I'm looking to the top, so it's created a larger angle, so it's not this plus this. Now if you wanted to find this angle, what's this angle right here if you really want? That would be a lovely 18. But what they told us just, nope, it's now angle is 53. Does that make sense to you? Good question. Does everybody understand what she was asking by that? She's wondering if it's 35 plus 53. I think that's what you were saying, right, Rebecca? But it's just you're looking at two different things, so hence you have two different angle measurements. Is everybody good? Okay. With that being said, notice this is x, and then this guy over here is the height of the smokestack. Okay, so let's build our two triangles. Because we saw two triangles, didn't we? Okay, one was, I love you guys. So proper and such. Okay, this is 200 feet, right? Sorry, that was appropriate. I thought it was alright. This is x, and how much is this? What's this? 35, right? So can we find x with that given information? It's just basically right triangle trig, right? So what trig function am I going to use? Tangent, okay? So I'd say, okay, tangent of 35 degrees. It's important to understand that it's degrees, because then you can make sure your calculator is in that mode, correct? And you guys missed points on the last test because your mode? Yeah, be aware of that, right? Make sure you're in the correct mode for equals x over 200. Okay? So we times that over. Now I think everybody can see that. It's pretty simple, correct? Right? So therefore, this is x equals 200 tangent of 35. Can I plug that in my calculator? Sure, plug it in. 140.04. Do I got a second on that? Second. Okay. Awesome. Anybody have a question? Is that what we were looking for? We were looking for the height of the smokestack. But why did I have to find the height of the building? Because if not, I had two variables for that height, didn't I? Does that make sense? So notice our second triangle. Now notice, I personally did not write down that measurement. Why? Am I done with my problem? So therefore, I should not plug that in yet, because then it would round it, and then it gets us all off a little bit, wouldn't it? Everybody understand that? Because when do we round? We round at the very end, don't we? Okay? Does that make sense? Okay. So then we have this other guy. Where, notice once again, this is the total distance of x plus h, technically, don't we? Does everybody understand that? Now once again, this is 200. tangent of 53 minus x, but what was x? We've already found that. No, we're not going to plug that in because that's already, don't do that, because why would you not go back and say it's the 140 point blah, blah, blah? Because you estimated, right? So we still want to keep it as exact, which is 200 tangent of, what again was it, 35? Equals h. Now plug it in, and now we are at the end, so therefore now we can estimate. Does that make sense what I'm trying to say? About how, I mean, you can kind of justify your answer at that stage, but still I want you to keep it as the exact answer, which is 200 tangent of 35, right? Does that make sense what I'm trying to get at there? So we got a second on that? Okay. Everybody understand? So once again, that came out to be, your height is 125.37 feet. I better repeat that because we were in feet with our distance away, correct? Right? Please, guys, come and tell me if anybody gets on tonight. Will you guys tell me and see if this really helps? Or if it doesn't, then I don't want to wear this thing. But if it does, I'll continue to do it. Okay? So please let me know. Somebody will let me know. But I'll shut up. Okay. Onward. Okay. Okay. Gotcha. Yep. Okay. So first off, if you look on the very top, they're talking about bearings. Okay. So, like when you're out on a ship or something, how they like to say it like, I'm going north 35 degrees east. What does that mean? Okay, so they're going in this direction to never eat shredded. I always did soggy waffles too, but I like the shred wheat. Or somebody said, never ever smoke weed. Okay. All right, so with that being said, I like the last one. You guys better understand that. Careful. So you're going north, but you're cutting back how much? 35 degrees east in easterly direction. Does that make sense? Everybody there with me? Yeah, did I do something bad again? Okay, you're always going to say north something east, north something west, south something east, south something west. You're always going to go opposite, because we're always going north or south, and we're going to cut it off east or west. Does that make sense? I will never say we're going east 15 degrees north. Most of the problems I've done has always been off north and south. I don't know if that's true or if they do that. I'm not sure. I'll be honest. My real world is teaching. I don't know what they do. Those are captains. The one that I go on with lobster, I think it's a dirty captain. Yeah, man. He has racist flags. And, yes, very dirty, foul language. Almost makes me blush if that makes you see. Hey, shush. Number 5. Here we go. It says the ship. I almost lost that one. Leaves port at noon and heads due west 20 knots or 20 nautical miles. That's what knots means, right? So basically, you guys know what nautical miles are? I don't know what that is. They're not. You can Google that. We'll Google that. So anyway, you can put your port anywhere. Put your port. There's my port! Identify that as your port. He says he's going due west. What does that mean? You mean it's straight as can be, right? We're not off at anything. We're right on west, correct? So we're going west. That's not due west, but it's the best I can do. Okay? And then it says, how far did he go? 20 miles or nautical, we'll just call it knots. Is it just NOCS or it is still the KN? Really? Oh, it is. Yep, it's still the KN. That was horrible. Let me try to get that better. All right, knots. Okay, he went 20 knots. And then at that time, which was 2 o'clock, actually, whoa, cancel that, preview, cancel. Then, whoa, forward that, okay? He traveled for 2 hours. So did he only go 20 knots? Because he was going 20 knots per hour. He traveled from noon to 2. How many hours did he travel? 2. So how many knots did he go? 40 knots. Does everybody understand that? That was a weird look to you, okay? Because he said he traveled, if you look at the story, it says the ship leaves port at noon and heads due west at 20 knots per mile, per hour, excuse me.
So he goes 2 hours.
So therefore 2 hours, that's 40 knots. Is everybody with me on that? Have you guys ever seen that video about what miles per hour means to that girl or whatever? Oh my goodness. We'll have to pull it up. At 2 p.m., the ship changes course, north, 54 degrees west. So he's at north, okay, so then you do a little north. I like to do a little T there. He's going 54 degrees west. So north, so this angle right here is 54 degrees west. Huh? Does that make sense? Is everybody there with me? North, 54. So this angle right here is 54. How long does he travel there? He says he changes course to north 34 degrees as shown as the figure for, does it say? No. Oh, find the ship's bearing at the distance from the port at 3 p.m. So at that distance he travels 1 hour, so therefore this is 20. We are trying to find how far is he from port. What's wrong with this picture though? This is an obtuse triangle. Have we ever dealt with anything but a right triangle? We haven't, have we? So, what we need, again, we're not going to cut it into two. We're going to kind of make it, as this right now, if I go ahead and pull him straight down and over, right? This is a 90-degree angle, isn't that? Does everybody see that? Yes, no, maybe so? Okay? So if this is 54 degrees, how much does this have to add up to be? Notice from this green line to the black line. Well, this part from, excuse me, let me say it again. This green line here, this that I'm putting it on to this green line is 54, but how about from here to here? It has to be 90, right? Because if I go from north to due west, that's a 90-degree angle, isn't it? So if he's 54 degrees, how much does this guy have to be? Does everybody understand why he's 36? Yeah? Okay? Alright, so he's 36 degrees. Now notice, ladies and gentlemen, I have two options here. See, this basically is the hypotenuse of that right triangle, isn't it? So couldn't I draw this a different way a little bit, saying, oh, well I have this thing right here, where this is 90. I don't know what this angle is, okay? But this distance right to here is 40, right? Okay, can I find this distance using this little right triangle? Yeah, I can, can't I? Okay, so I'm standing here and I'm going to put this guy as X right now and I'm going to call this Y. Okay? Alright, so if I'm standing here, what does the X represent in the little right triangle? Adjacent, what is the, notice this is not 54 for the length, this length, remember, is how big? 20, so in E is the hypotenuse. So which trig function am I going to be using? Cosine. So I say, okay, cosine of 36 equals X over 20. Does everybody understand that? Okay, times the 20 over. 20 cosine of 36 equals X. And isn't that amount right there? So what's the whole base of how far he is away, like westerly? Does that make sense what I'm saying? How far is he away westerly? 40 plus this amount, isn't it? Does everybody see that? Okay. Okay. Come on, do I know that angle? Hold on. So I was just wondering, so this guy right here is 20 plus, no, not plus, cosine of 36, right? I got it. Give me a second, because I haven't looked at the picture of what there is. I'm just trying to figure it out myself here. Just making sure. Okay, so now what I'm going to do is I can find this height really easily as well, right? How can I find him? Because that could be, we could call him Z, couldn't we? Right? How could I find him really easily? I could do, well, I could do Pythagorean theorem, couldn't I? Where 20 squared minus this stuff squared would equal him squared, right? Or I could just say, okay, I'm standing here, so therefore Z equal over 20 equals the sine of 36. Okay, so then we times it over, so Z equals 20 sine of 36. So that's this guy right here. Okay, so now how are we going to find that last distance? Now that's Pythagorean theorem. How? We don't have an angle. You could. Where? Okay, yeah, I could, but it's really not too hard. Let me show you where you're going to get this. Because isn't this technically one side? Right? This is one side. And then that's going to be something squared, right? And then what do we do in the end? Take the square root. So everybody, I'm going to go to my calculator here. What mode do I need to be in? Degree. So everybody make sure you're in degree mode, because I know I'm not. Okay? So what I'm going to do is, once again, understanding that is this 20, put it in parentheses. I should have did that first. 20 is sine of 36 squared, right? Because that's that side, correct? Plus the following side. What's this side right here? 40 plus 20 cosine 36 close, right? Square that. Okay, that's Pythagorean theorem, wasn't it? Hit enter. That's what it is. Now what do I need to do to that? That's y squared right now, isn't it? So then I like to just caret it to the 0.5, because remember, something raised to the half power is the square root, right? So he's 57.397 nautical miles away from port, which is on a straight beeline. Does that make sense? So obviously, that kind of understands as well, right? Isn't a straight line obviously faster than 40 plus 20? Maybe he had an island here. I don't know. But notice, if we check at it, we get the same 57.4. Pretty kosher, eh? I like these problems. Once again, I like these problems. I don't know. Harmonic motion, okay, which is on the top of 256. I do these problems not because of my interest. I do these problems because there's people in the district that have interest with this for some reason, and they love some springs, okay? And they also love, let's see if it's on there. Ooh, oh, yep, definitely. A wave. Okay? So, a spring. Okay, if it's just normal, let's say here's it's hanging off of, right? So normally a spring just likes to sit here underneath this. Let's say it's 5 inches away normally. Okay? But then when it is, I don't know the correct word, oscillated or pulled or whatever you want to call it. Okay? Displaced, that's what it's called. When it's vertically displaced, it goes a lot further, right? scrunches really tighter than what it was normally, right? So let's assume that this went all the way out to 9 inches. Okay? And then, obviously, then it retracts, right? Then it comes back to its normal spot. And then it's going back in because it has so much force, it's still going back up towards the board, right? Can anybody tell me how squiggly this line should be? How far should that be away from the board? Why? So it went away from the normal, its displacement was 4 inches, so it's going to go displacement in as well, 4 inches. So I've never taken physics. Yes. And then I quit. Yeah, shut up. Well, no, what is its full displacement? If I gave my example, we're trying to do something different than what we're doing. So we're usually 5 inches away. You could also consider that kind of your midline as 0 in a way, right? But I'm talking about your length away from a board. So that's what I'm talking about. Okay, yes. Would be. Okay, because notice you're pulling it, because notice, look at this. Then after a while, he figures, well, you know it's pretty good. We're just going to assume he comes back to his original list. Because what does that make it pretty? It's like a sine graph, right? Okay. Or if you think about an ocean, look at the waves. You ever look out at waves, right? It comes that way. It has a very harmonic feel to it, right? Yeah, so therefore, this distance right here is what? 4. How long does it take for it to get all the way back? Let's say it takes 6 seconds. Can somebody tell me what this is? How long does it take me to get from here to... that's really sounds really long. But anyway, keep going. So if this was 0, how much is this? And this is 6. How long did it take you to fully compress that? 1.5 seconds, right? And this guy would be 4.5 seconds. So could we write an equation of this? You ready? Isn't that what, remember, sine and normal for inverse, right? Anna, you got a question? I just told you that it took 6 seconds to come back to its original weight. What does it say in here? Harmonic motion. From the spring you conclude that the area, for example, consider a ball that's bobbing on down at the end of a spring as shown. If the maximum distance the ball moves vertically, upward, or downward from its equilibrium, or its rest position, is 10 centimeters. Suppose further the time takes the ball from doing its maximum displacement from 0 to the maximum displacement of 0 and back again is 4 seconds. It's kind of like decoding all that, right? That's sometimes why you guys struggle with math problems and reading it, because you're like, I'm reading a different language and what part's the important part and what's not, right? So as I'm going through here, for example, consider a ball that's bobbing, blah, blah, blah. Suppose 10 centimeters is the maximum distance the ball moves vertically, upward, and downward. So the biggest it's going to go down is 10, and away from this is 10 as well. Does that make sense to everybody on that problem in the book? Okay. Now, from its equilibrium rest position, suppose further that the time it takes for the ball to move from its maximum displacement above 0 to its maximum displacement below 0 and back again to, where does that mean? Where does it mean back again? Back at the midpoint, right? It takes 4 seconds. So notice for everything they're doing, that would be 0, 1, 2, 3, 4. Does that make sense? Because remember, what do we always have to do? It always has 4 equal increments, right? We cut that in 4, so that's why it'd be 1, 2, 3, 4. So for me, I cut it in 4. That's how I got 1/2 root 3/2, or excuse me, 3/2, 4.5. Does that answer your question? Is that my question? Some of you do. Okay? Love you all. Okay, so with that being said, we can write this because notice, what is our period? 6. What's our amplitude? With that being said, we can say that, let's say for us, I. Sure. Are they using oxes and everything? Are you going to put a poster saying, do not touch this door? That's right, you will. Love you, Jersey A. Buy my favorite Native American. Oh, I will push Paul. Zipper was down. I don't know why. Because yesterday my zipper was down. These pants and struggle. Onward. Okay, so with that being said, this is a sine graph, right? And we know it's a negative sine graph. What's our amplitude? 4. So this would be -4. Anybody have a question there? Could we have a midline here? Yeah, our midline is 5 inches away, right? Does that make sense? Well, I guess this would be positive still. If we think about it, it would be positive because we're talking about our displacement away from it. If we think about it away from, isn't this a positive 4 inches away from, or 9 inches away from the board? So it all depends. It's okay. Either or, I'll accept either or. Basically. So now, yeah. Well, it all depends on what we're looking at. Okay, now we're seeing it downward, right? Now I can understand what you're trying to say by that. Let me explain, hopefully. How are we doing time-wise? Good. All right. We're good. Okay. Let's try to get over this because I want to do one more problem. More important than this one. Okay. So with that being said, if we're talking about the distance away, can you really have a -5 distance? That's kind of why I did +5, and that's why I'm going to consider this +4, because I know you're 9 inches away, you're 1 inch away. Does that make sense? Exactly. Exactly. That's kind of what I'm thinking. Because you're always going to be consistently 5 inches away, but the farthest you're going to be is 4 plus that 5, which is 9. The closest you're going to be is, notice this is going to be -1 times 4. That'd be -4 plus 5, and that's 1. Does that make sense? I can understand because if I looked at this picture normally, yes, that'd be -5, yes, that'd be -4, but because we're kind of thinking about it with the displacement away from the board, that's why I was doing it this way. Okay, last thing. Our normal period is 2 pi, right? But it took us 6. How did we get there? 2 pi times what? Remember the reciprocal, right, of b got us to 6. So how do I do it? Go ahead and solve. All I do is times the b over and divide the 6. So 2 pi over 6 equals b, which is what? Pi third theta or x, whatever you want to say. Or t in this case is time, huh? You have to have pi in here because then you're going to times by its reciprocal. Anyway, just think about how you can make a wave, how you can make something from that graph that's on the end of your that's all. I wouldn't care, I played around with it. You don't have safety testing. This is not a required class. We do not have safety testing. We have a district engineer on here testing. And it is on your grade. Because if I don't, then you don't take it seriously, right? Like, you can affect somebody last year from an on page 359, you're looking at 34. Oh my hell. 360,
Okay.
number 34.
Okay.
But first off, I'm going to get your assignments really quick. Okay, number 15, 18, 21, 25, 29 and 31, 34, even though I'm going to go over it with you, I want you to practice. 37, I'll call that good. On possession. Okay, so notice I kind of going to set it up. I'm not going to help you all the way. Although we have a fire. Okay, we got two lovely towers and another tower. These are balloons. Let's search out things and stairs. I don't know. I'm not an artist. Okay. Anyway, these two towers are, what does it say? They're 30 kilometers away from each other. Okay? You can say miles if you prefer miles. It doesn't matter. So it says two fire towers are 30 kilometers apart. We're Tower A, so we'll call him A. Usually the left one would be A and this one's C. Okay? With that, darn it. Oh, it is going. Okay. So Tower A, where Tower A is due west of Tower B, so they're straight across from each other. A fire is spotted from the towers, and the bearings from A and B are as follows. So this one actually does use an east one. So it's east, cut back 14 degrees north. So here's our fire. Fire! He's with this angle. So he's going east, cut back 14 degrees north. This is 14 degrees. Everybody understand that? Yes, no? Because he's right here, cutting back north. So it's, like I said, I guess, either way. This is going easterly, cut back. I didn't think they were going to have many problems because I guess I can remember this one. Most of the ones I've seen on the navigation ones are usually north, cut back west, and so forth. But this one's east, cut back north. 14 degrees. Isn't that what it says? And then the other one says it's west, cut back north, how much? 34 degrees. So going here, notice they get to the same point, this is 34 degrees. Okay, once again, is this a right triangle? So can we find this distance? They want to know, what does it say? Find the distance D from the line segment, or basically from that westerly parallel line. Right? So how far is this away? Now did I form two right triangles? Yes, I did. Okay, the only problem is I don't know how far the fire is from this guy westerly. Does that make sense? And how far it is from this way. So I gotta call one of these guys X. Does it matter which one? I'm gonna call him X. I'm gonna even highlight him in red. He is X. So he is X. What's this distance? It's not X plus 30. Because X plus 30 would give us a bigger distance than 30, wouldn't it? This is 30 minus X. Does that make sense? Because notice if this guy's 14, this would be 16 because 30 minus 14 would be 16. Exactly. Okay? So now with that being said, I got two triangles. Okay, so I'm going to stand here at 14 degrees. Tangent of 14 degrees equals D over X. So X, tangent of 14 equals D. This one, okay, is tangent of 34 equals D over what? 30 minus X. So therefore I times tangent of, is it 34?
Yeah.
Minus x tangent of 34. Did everything with an x to one side. Equals 30 tangent of 34. What do those guys have in common? Pull out the x. And then just divide that over. That tells you x, but is that what we were looking for? So then, notice, remember, after you find that x, go back up into one of the equations that said solve for d, and you just transfer it up in there. Does that make sense? Okay.
We can, you have one as well.